Well, howdy. This is not the funny cat video you were looking for. So I guess I'll just have to teach you how to write polynomials in factored form. Meow. All right. Let's see. So I have a polynomial here. Given factor that x minus 8 is a factor, we want to get the rest of the factors out of this. So the big idea is that there should be at most 3 factors of this from the degree here. So there's up to 2 more factors besides this one that we don't know. And so big idea is we want to think about get rid of the thing we do know so we can focus on the things we don't know. And so since I know that x minus 8 is a factor, I want to get rid of it first. And so we're going to divide it out. Right? Factors are things that multiply. So I want to divide it away. So to do that, I'm going to use synthetic division. So I'm going to set up my box. I want to look for gaps in the dividend. So 3, 2, there should be an x there. What was I doing? X, 3, 2, 1, and then 0. So no gaps. So I'll bring down those coefficients. I got a 2. I got a negative 25. I've got a 37. I've got a 280. Who wrote this problem? 280. Good golly. And then since our factor is x minus 8, our 0 of that factor will be positive 8. Right. So the 2 comes all the way down. Don't do anything to it. Boom. 2. Then we're going to take the 8 times the 2, which is 16. We're going to add that. Negative 25 plus 16 is negative 9. 9 times negative 8 times negative 9 is negative 72. And negative 72 plus 37 is negative 35. And then times 8. So 8 times negative 35 is negative 280. Well, that's convenient. Negative 280. Of course, we should have known that was going to show up anyways, because how else were we going to get 0 there? And we knew we needed 0 because we were told that was a factor. So remainder of 0 means that this is a factor. So then I want to label my pieces here to write that resulting polynomial. So I got remainder constant x squared. So we are looking at 2x squared minus 9x minus 35. We need to continue factoring that. And so we're going to use the AC method to do that, since that has 3 terms. So we're going to take our A value and our C value. So our A value is 2, our C value is 35. So that means our AC is negative 70. And then we need that to add up to negative 9, our B value. So I want that to add to negative 9. So I want to find factors of negative 70 that add to be negative 9. So let's factor negative 70. So factors of 70, so 1 times 70 is 70, 2 times 35 is 70, 3 doesn't go into 70, 4 does not go into 70, 5 goes into 70 14 times, 6 doesn't, 7 does 10 times, 8 doesn't, 9 doesn't. So those are all the factors of 70. We need to get negative 70 and negative 9. So that's going to come from these 2 guys right here. Positive 5 and negative 14 will be negative 9. So we got 2x squared plus 5x, positive 5x, and then minus 14x, and then minus 35x. Right, so 2x squared didn't change, negative 35 didn't change, but negative 9 got split into positive 5 and negative 14. So these 2 add together gives it right back to here. So didn't change the problem, just change the way it looks. Cut it in half and ask yourself, what do these 2 have in common? These 2 both have an x in them, so that x needs to come out. X times 2x is 2x squared, and x times 5 is 5x. And the next two, what do they have in common? So 14 and 35 both have 7 in them. You take out a negative 7 since that's negative. So minus 7, it's not a 7, 7. And then negative 7 times positive 2x would be negative 14x, and negative 7 times positive 5 would be negative 35. And then these two binomials being the same tells us we're on the right path. Let me group everything again. Oops. And then the 2x plus 5, those come together. The x minus 7 goes together. And don't forget about that original factor that we were given of the x minus 8. And so f of x is equal to all that. So a couple of quick things you can do to kind of check to see if your answer makes sense. Really basic one is that there's 1, 2, 3 x's here, and then we have an x cubed. That's a really basic one. Or a little bit more advanced would be like 2x times x is 2x squared, and times x again would be 2x cubed, so that matches. And then a little bit further, be negative 5 times, or 5 times negative 7 is negative 35, and negative 35 times negative 8, so in your calculator or whatever, is 280, positive 280, which is what this is. So you know, 2x cubed, and then the 280, those match. Pretty good chance that these match here and inside also, but we don't have to check them. So we can kind of see if our answers make sense. Suggest you spend just a minute doing that before we move on. All right, let's do one more and we'll be done. All right, so similar problem here. We've got 3x to the fourth plus 19x cubed minus 14x squared minus 108 plus 72. And we're given that these two things are factors. I'm going to write the whole thing in factored form again. So I'm going to do that same way. We're just going to get rid of those factors individually. So we're going to get rid of, just like we did in class, get rid of one, then get rid of the other. Doesn't matter which one you do first. I want to check for gaps. So 4, 3, 2, 1, 0. No gaps. Still important to check for them. Set up the box. So I got a 3. I got a 19. Negative 14. Watch your signs. Negative 108. 72. I will get rid of the x minus 2 first. So I need a positive 2 there. Drop down the 3. 2 times 3 is 6. Add those together. Should get 25. 2 times 25 is 50. Add those together, get 36. 36 times 2 is 72. Add those together, should get negative 36. And 2 times negative 36 is negative 72, which is good, because that gives me 0. So we do see that x minus 2 is a factor of 3x to the fourth, blah, 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 because the remainder was 0. So we're going to do another layer of synthetic division right below that. We're not going to draw a new box or anything. I'm just going to come right below that. So in the box. What I don't need is I do not need the remainder, because it wasn't even there. So shorten up my box some. And then I need to bring over the 0, which is going to be negative 3, since that says x plus 3. And then start her over. Boom. 3 comes down. Negative 3 times 3 is negative 9. Add, that gives me 16. Negative 3 times 16 is negative 48. Negative 48 plus 36 is negative 12. Negative 12 times negative 3 is positive 36, which is awesome, because that gives us 0. And so that, again, tells us that, it confirms that x plus 3 is indeed a factor of our original polynomial. So we are left with this. There's our remainder. There's our constant. There's our x. There's our x squared. I'm going to bring that up here. So that gives me 3x squared plus 16. plus 16x minus 12. So again, we're going to need to factor this using the AC method. So our A is 3, our C is 12, so our AC is negative 36. We need that to add to 16. So factors of negative 36 add to be 16. So I got 1 and 36, 36, 2 and 18, 36, 3 and 12, or 36, 4 and 9, or 36, 5 does not go into 36, 6 and 6 or 36, and there's my loop because it's a perfect square at that point. Nothing else will go into 36. So now I need to find negative 36 and 16, and that's going to be a 18 and a 2. So I need a negative 2 and a positive 18 to get positive 16. 3x squared minus 2x plus 18x minus 12. Cut it in half. 3x squared and 2x both have a x in them. That's it. X times 3x and x times negative 2. 18 and 12 both have 6 in them. It's positive 6, so plus 6 there, not just 6, plus 6. 6 times 3x is 18x, and 6 times negative 2 is negative 12. So again, there's our binomials that are the same. That's good. Things are working. We're almost done. It's getting so close. And so then the 3x minus 2 is one of our factors. X plus 6 is one of our factors. And don't forget about that first one from the beginning, or first ones. X minus 2 is one of our factors, and x plus 3 is one of our factors. Lots of factors, which should make sense because this was a quartic, a 4th degree problem. We have 4 factors. So g of x is equal to that. 1, 2, 3, 4 x's, x to the 4th. 3x times x times x times x is 3x to the 4th. Negative 2 times 6 is negative 12, times negative 2 is positive 24, 24 times 3 is 72. It's looking good. Go forth, do good things. See you guys later.